Now let's talk about multiplying and dividing rationals. If I want to multiply rational expressions, let's say I have x squared minus 1 over x squared plus x, and then times 3x plus 9 over x squared plus 2x minus 3. If you want to multiply these things, keep in mind that for multiplication and multiplication only, not addition, not division, but for multiplication you can cancel things out up and down or diagonally, never left to right. Now before I can cancel those things, I have to factor to see if things are actually the same. So I have x plus 1, x minus 1 is how I'm going to factor that first thing. Here, well, I can't square root both things and I'm not subtracting, so I'm just going to factor out an x and get x times x plus 1. And then here, I'm going to factor out a 3 and get x plus 3. And then on the bottom, quick, easy factoring, because there's nothing in front of the x squared. I get x minus 1 and x plus 3. I needed two things that multiply to give negative 3, add to give positive 2. Now I will cancel out diagonally here, cancel up and down there, cancel up and down there, and only thing left over now is 3 and x, so I multiply the tops. I get 3 on the top and x on the bottom. And that's how you multiply. Okay, now I want to try a division problem. So let's do x plus 5 over x squared minus 9. All of it divided by x squared minus 25 over x squared plus 7x plus 12. Now, what I'm going to do here is I'm going to make use of a rhyme. It goes like this. When the fractions say divide, invert the second and multiply. So these fractions are saying divide, invert or flip the second, and multiply. I actually made this up, and people stole it from me, though. In fact, some people stole it from me and were using it before I was even born. That's how sneaky they were about stealing it from me. I don't know how they did it, but I'm going to figure it out because I made it up first. So someday I'll probably write a book about it, and if I ever do write a book about it, you'll have to pay me a quarter every time you say that rhyme. So I don't know. Okay, so now I flip the second fraction. I get x squared plus 7x plus 12. And on the bottom I have x squared minus 25. And now I just have a multiplication problem again. So I factor where I can. Well, x plus 5 can't be. But x squared minus 9 is the difference between squares. And then over here, x squared plus 7x plus 12. Oh, that's a trinomial with nothing in front of the x squared. So I need two things, multiply to give 12, add to give 7. How about 3 and 4? Does that work? I think so. And then on the bottom, another difference between two squares. It's going to be x plus 5 and x minus 5. And now, for multiplication only, because this is now a multiplication problem, multiplication only, not addition, not division, you can simplify by crossing out diagonally or up and down, but never side to side. So it looks like I've canceled everything I could cancel. Final answer, x plus 4 on the top. On the bottom, I have x minus 3 times x minus 5. And I'm going to have you leave it that way. There's no need to FOIL it out because sometimes it's actually more helpful to keep it factored. It just kind of depends on the situation. One other thing I want to talk about here is the domain. Okay? For this problem, we actually have three things to worry about. First of all, we don't want this to be 0, so can't equal 0. We also don't want this to be 0, but there's a third problem that may not be obvious to you. We don't want this whole fraction itself to be 0 because this whole entire fraction is also a denominator for the bigger problem. So if this whole fraction is 0, that happens when this part is 0. So actually, we don't want the x squared plus 20 or x squared minus 25 to be 0 either. So what things do I have to exclude? Well, x squared minus 9, when I factored it, I see that x can't be plus or minus 3. That would be bad. And x squared minus 25, when I factor that, I see that it can't be plus or minus 5. That would be bad. And here I also see that x can't be, well, looks like it can't be negative 3. Well, we've already got that, so I don't need to write it again. but it also can't be negative 4. So the domain is all x such that x is not equal to those things. There's my set builder notation for you too.